Find the equation of the line tangent to f of x equals 1 over x at x equals 2. What we're going to use is a version of the point-slope formula. Y equals m times x minus x1 plus y1, where x1, y1 is a point on the line, and m is the slope, which will be the instantaneous rate of change of the function at the given point. So let's start with the slope. Will be the limit as h goes to 0 of f of x plus h minus f of x over h. And our given x value is 2. So we're going to plug in 2 for x. This is equal to the limit h goes to 0 of 1 over 2 plus h minus 1 over 2, all of that over h. One way we can simplify this fraction is to multiply the numerator and the denominator by those two denominators in the numerator. So by 2 plus h times 2 over 2 plus h times 2. That will give us the limit h goes to 0 of 1 over 2 plus h times 2 plus h times 2 is just 2, minus 1/2 times 2 plus h times 2. The 1/2 and the 2 cancel to give us just 2 plus h over h times 2 plus h times 2. This is the limit as h goes to 0. If we subtract both of these terms here, we're going to get 2 minus 2 and negative h over h times 2 plus h times 2. And then we can cancel out h over h. That will leave us with limit h goes to 0 of negative 1 in the numerator over 2 plus h times 2. Now we plug in h equals 0 and evaluate this limit. That'll be negative 1 over 2 plus 0 is 2 times 2. So negative 1/4. So this value is our instantaneous rate of change, which is our slope. The last thing that we need is a point to find the tangent line. We know our x value. This is our first x value, x1. Our y1 would be plugging in that x value to the function, so f of 2 so 1 over 2 is our y1 value. And now let's plug into our point slope form. Y equals m, which is negative 1/4, multiplied by x minus x1, which is 2, plus y1, which is 1/2. And we can simplify this a little bit. y equals negative 1/4 x plus 2 over 4, which is 1/2, plus 1/2. And our tangent line is y equals negative 1/4 x plus 1.